Please put your hands together for Marek.
Hi. I'm assuming I am audible. Okay, great. That's the first moment I heard my microphone go on, so excellent. Thanks everybody for coming. Thanks to Hardware Pioneers Max for hosting, and thanks to the folks from Particle for all the support so far. If there's like a central kind of objective that I have for this particular talk, it's the idea that really there is no single, ubiquitous, universally available connectivity solution for a globally distributed industry. It just doesn't exist. It really, really doesn't exist, at least in my experience thus far. So I want to talk about the sort of different ways that Particle has navigated this particular complexity and what our particular solution to this lack of a univocal solution for connectivity is at the edge. So first, a little bit about me. That's right, I'm not Zach Sapala. I'm a younger but less cute version of Zach Sapala. Zach's our CEO and founder. But I feel like I'm a particularly good person to situate in this context because I am the person at Particle who has spoken to the most customers about their use cases. I've talked to hundreds upon hundreds of people who have deployed Particle or chosen not to deploy Particle in all kinds of industrial use cases, agricultural use cases, remote sensing use cases, med tech use cases, everything across the gamut. And the vast majority of those conversations have been around connectivity. I sit under product and sales and CS and a little bit of engineering, and I run solutions architecture, sales engineering, TAM. You can tell it's a mess. It's quite an octopus that I'm in the middle of, but I'm very, very happy to be in that particular position. A little bit about my background. So I have a pretty unusual background, which I always kind of like to highlight in contexts like this. My background is in philosophy of science, especially as applied to computation, and also in fine arts. So things that are in the intersection between soft robotics, machine learning, and theoretical computer science. Just released a book last year on machine learning and theoretical computer science that's pretty crazy called Koriyamata. And I actually came across Particle because I was using Particle devices to monitor the health of all kinds of installations, art installations that I was exhibiting throughout Europe. Sent them an email, and then 5 years later, I've been at Particle for quite some time and having a good time. But as much as I'd love to talk about soft robotics and theoretical computer science with you guys, that's not what I'm here for. I'm here to talk about Particle and our solution to this problem of connectivity at the edge. So first, what is Particle? We are a hardware-enabled edge-to-cloud infrastructure provider, which is a very pretentious way of saying IoT, right? But it's more than IoT. It's really a dispositional shift from what IoT actually is, and that we really provide everything. We provide 100% of the material media and the logistical infrastructure required to connect a thing to the cloud. That's everything from a hardware portfolio to a network stack to vendor management of mobile virtual network operators, so the entire cellular stack, the radio stack, an abstraction layer in our operating system to manage all of that, data pipeline, a secure data pipeline with co-op over DTLS, a platform, data management, data infrastructure, Lambda functions, digital twins, and then outbound integrations. Quite a mouthful, but that really is what we do. Really, the goal is you have a thing, you want to connect it to the internet in an enterprise forward sort of way. Here is a single monolithic object solution to the problem of connectivity. So yes, what I've learned, at least in the conversations that I've had with the many customers I've encountered, is that's what a lot of people want. A lot of people, I was just talking to someone the other day who was ideating about a connected lighting use case and the complexity of spending 80% of his time focusing on the connected component of that connected lighting use case, as opposed to the actual lighting component. He's a lighting guy. He wants to talk about lighting. He's engaged with lighting. That's what his engineering team is spun up to handle, not the incredible and principally non-technical stack of handling connectivity throughout that entire layer. So historically, we've primarily worked with Wi-Fi and cellular as our main connectivity modes. Obviously, other protocols like BLE, NFC, GNSS, other situations as well. Every single kind of serial protocol in the books in order to connect the hardware physically on the ground. But so these applications have been used in all kinds of situations so here's a Wi-Fi use case, Anytime Fitness in Minneapolis. They do remote door access control They use a Wi-Fi enabled and BLE enabled device to handle the opening and closing of that door. And they use our digital twin infrastructure to send and sync payloads of access up and down from the cloud. Here's ColdJet. They are a dry ice spraying company who uses us for equipment monitoring and operational efficiency. This is Moxion, one of my absolute favorite use cases. They are a sustainable generator company. This is a massive, massive battery that's deployed to all kinds of events, functions, operations that they track and do preventative maintenance for with our product. And then this is the Maine Department of Marine Resources, who uses us for lobster trap tracking. So really everything, like the gamut of people that we're talking to is just the entire kind of breadth of connected anything. So I want to talk about a specific problem with this particular array of technologies, which is that a given use case is kind of matched with a given connectivity solution. So you have Wi-Fi for your door access control, or your wired payment monitoring solution, or your electric vehicle charging solution. And then you have cellular and maybe with GNSS for your asset tracking use case, or your emissions monitoring use case, your remote sensing use case. And I think, you get this kind of bifurcation in terms of how people are actually leveraging these connectivities on the ground. And I think most people, if not everybody, kind of underestimates the amount of contingency at the edge once they actually move to scale a connected device. So I just visited one of my absolute favorite customers, Sensotech in Belfast. They just won Small Business of the Year in Belfast, though I don't think they're technically still a small business anymore. They do something that's absolutely incredible. They do vibration sensing. My PhD is in DSP, so I was there super nerding out about the fact that they are taking waveforms, they're measuring vibrations on some heavy industrial machinery, and then they can, looking at sidebands, doing some amazing DSP, tell you this bolt in this particular part of the machine, the inside of that needs some lubrication. That's unbelievable to me. Like, that is a truly intelligent machine use case of a kind that I've never actually seen before. But the thing about Sensotech is that they deploy everywhere. So they partner with pharmaceutical manufacturing companies. They partner with massive industrial scale manufacturing. They work with pneumatic drills and offshore drilling and mining and all these different use cases that have all kinds of specificities in terms of the actual connectivity environment available to them. And the real complexity there is that Sensotech has 20 different ways that they use our product at this particular point. They have this huge proliferation of different gateways that, meet this connectivity need, meet this connectivity need, meet this connectivity need. And so as they maybe encounter that in one particular use case, that might not be the best Wi-Fi infrastructure, we're going to actually send a cellular infrastructure out to go meet that particular use case. That's a problem that results in this kind of proliferation, which is obviously logistically quite challenging. And they've also told us that cell and Wi-Fi, they do not cut it 100% of the time. Obviously, I mean, we all know that. It does the majority of the trick, but when you're deep in the desert, or you're far offshore, or, whatever, deep in some kind of industrial warehouse, or I was just talking to someone about tunnels, these are not, you can't just use Wi-Fi and cellular to meet that 100% guideline. So we really wanted to think to ourselves, how do we solve for essentially 100% availability without coming across this SKU proliferation problem necessarily? But first, we went after the 100% problem. So this feedback from amazing customers like Sensotech has encouraged us to drive deeper into the LP WAN side of the house. So looking specifically at LoRaWAN, looking at NTN solutions, we've already done quite a lot with LTE Cat-M. And so, we're starting to dive a little bit deeper there. So LoRaWAN, of course, is a great fit for industrial environments, for private networks, for academic institutions, for kind of deep internal spaces, basically wherever you can put a gateway, right? Anywhere you can put a gateway. Essentially, it's a much, much cheaper solution for factories right now who are, in a lot of weird cases, actually erecting 5G towers inside their warehouses in order to sustain some sort of internal connectivity. Obviously, LoRaWAN is a much more, cheap effective solution in a lot of cases. It's like also more effective than even maintaining complicated enterprise Wi-Fi, especially across like a broad distribution of industrial workspaces. So we partnered with Helium, with Things Industries, and with Comcast MachineQ to deliver a tremendous amount of availability via LoRaWAN. Helium is really interesting. I'm sure probably a lot of you are familiar with Helium. They started as a kind of decentralized crypto network that has, in its kind of movement and proliferation outward, left behind this enormous infrastructure of LoRaWAN gateways. Like 80% of the US population has access to the Helium network through a LoRa connection, in basically the same sort of protocol that one would engage with a cellular network over. Then the Things Industries, that's a great solution for people who want to like manage their own LoRaWAN network. They have like 1.5 million devices connected via LoRaWAN right now. And then one of the cooler ones is Comcast MachineQ. So with Comcast, you know, they're actually delivering a real tier 1 support solution. Like, just like you can get a truck roll for a Comcast Wi-Fi problem, you can actually get a truck roll for a Comcast LoRaWAN problem now, which is definitely something that LoRaWAN hasn't had previously, is that kind of support in the past. So we wanted to push a little bit further. Like, you know, LoRaWAN adds a little bit. It definitely gets you kind of deep in a space. It maybe gets you deep in a tunnel, but it definitely doesn't get you deep into a desert necessarily, or deep offshore. So we wanted to push again, how do we get towards that 100% availability regardless of location? So NTN, that's really what we started to invest in, non-terrestrial networks, ideal for the remotest of applications. We're thinking about folks that are working in first alert tide monitoring, a lot of ecological use cases, emissions monitoring, like way out in ecological kind of situations, weather stations, and then of course industrial applications in mining and in drilling. So yeah, I mean, we didn't spin up our own satellites, though that would be pretty fun, but that's definitely, you know, it gets a little bit expensive. So we partnered with Skylo to leverage their NTN network. We're using the BG95S5 by Quectel, which is amazing to accomplish that, which allows us to essentially contact with an NTN network via similar looking protocols to something like LTE Cat M1. And we do a tremendous amount of the overhead work natively within our operating system in order to keep the actual message side down. If I was to ask this crew, what's your first response to the word satellite? I think expensive is the word that comes after it. So we've been able to kind of push the cost down to about a fifth of a traditional satellite uplink. But now we return to the main problem, right? If you approach 100% coverage, but it's done through adding more connectivity layers, adding things like LoRaWAN, adding things like satellite NTN, you can get a huge combinatorial matrix of different SKUs that you're trying to deploy to the edge to meet this or that specific use case. So our solution, of course, is to combine radios together on one board and deliver that kind of it just works anywhere solution. And this is where we really start to talk about abstracting the problem. Instead of this or that particular solution, instead of like, I want to connect this thing this way or this thing this way, like customers come to us for connectivity as like an abstract concept. So we deliver that abstract conception of connectivity. That's our focus for delivery. And I'm going to recur a little bit to the idea of abstraction. I'm not going to belabor the point too much, but this is the actual hardware itself. Definitely would love to talk to you about it in the booth. We have the M series, M for multi-radio, which supports a multiplicity of radios simultaneously. And I'll talk about how exactly it does that. So of course, in moving to multi-radio, all we've done with that SKU proliferation problem is move that complexity inwards a little bit, right? Now we have one object, one module that has a bunch of radios on it, but interacting with a bunch of different radios is of course complex for these particular reasons. They different radios excel at different things, and moreover, they have profoundly different needs. So, this could essentially collapse into, some application firmware run by a user being like, I want to send this message this way, and I want to send this message this way, et cetera, et cetera. That's complicated. So, the first thing that we did is to abstract that connectivity layer entirely, leaving it available to customers who want that kind of deeper level of customization, but providing a solution that's available under a single API wrapper, particle.connect. You call particle.connect in your firmware and the device connects. it figures out how to make its way to the cloud. I'll talk about the algorithm for that in just a second. So yeah, again, customers come to us for connectivity for that entire solution, not for this or that solution. There we go. Okay. Oh. There we go. Okay, sorry. We call the way that we handle this automatically on the chip side ACM, or automatic connectivity management. We provide a autonomous operation mode. So basically our operating system will decide, like, here, we're in this particular place. We know what's around us in terms of connectivity availability. Here's what we're going to kind of prioritize in terms of what's available. If connectivity is struggling at a given location, well, we'll check certain availability metrics, RF metrics, packet loss, data integrity metrics, and say, okay, this is probably a good idea, a good context for LoRaWAN, or a good context for a cellular connection. It'll also remember that information, store it, and then the next time it tries to connect in that location, it'll automatically prefer it. For folks that are looking for a little bit of extra hierarchy, a little bit of extra control, we do provide the ability to actually specify a ranked ordering of connectivity, interfaces that one might prefer. So obviously there are contexts where a customer is thinking of us as a Wi-Fi enabled product with a cellular, with a cellular backup. And so that's a particularly good situation for this. You can specify, I'll talk to you directly. You can specify Wi-Fi first, but then you can allow for that cellular backup in situations where, well, that Wi-Fi isn't being served up on the edge, maybe how you'd actually like it to be served up on the edge. As we all know, Wi-Fi on the edge is actually incredibly complicated because you're, opening yourself up entirely to the contingency of your customers, right? And then in addition to that, we do also offer a socket API for people who really want like a specific context to send a message. So if you're like, this message really needs to go out via satellite, call that socket API, and you can address that interface directly. At the same time, all of this leaves up the ability to keep a local network interface up, so you can have a LAN with an Ethernet connection, pulling information locally and managing things that way without disturbing the connectivity layer. So we've solved connectivity by abstracting it, but messaging then becomes complicated because the way that these different radios actually send things is, profoundly different from radio to radio. And again, just like customers come to us for connectivity, customers come to us for messaging. They don't come to us for, oh, I want to send MQTT in this particular way to this particular output with this particular kind of codecs around it. No, customers want to send something somewhere in a secure and reliable way. So we provide messaging. We don't provide an insecure, brittle matrix of like a way for you to do messaging. We provide the entire messaging infrastructure. So we abstract everything into an event system, essentially just like the single wrapper for connectivity, particle.connect. There's a single wrapper for messaging, particle.publish. Instead of sending, unencrypted MQTT or, just shooting out UDP packets anywhere, we use a low overhead DTLS over CoAP protocol that is encrypted as it leaves the device and then unencrypted as it hits our cloud. Really, really nice infrastructure for doing that. Particle.publish uses a variety of different data types increasingly. As of next month, we have, not just strings, but JSON, raw binary data, and compressed data types as well. And the size of a particle publish continues to increase, moving to about 16K next month. And then we have some announcements around sending even larger payloads later in the year. So, a LoRaWAN message and an NTN message and a Cat M1 message, they do want to go in specific ways, but there are filters and priorities that can be set within device OS to make sure that the message that you're trying to send is going out through an interface that actually really does make the most sense, taking into consideration the kind of context of the connectivity layer on the ground. And actually, like, another thing to note is that like that event structure is monolithic and operates throughout our infrastructure. So you send a particle publish and it goes to our cloud where it can be, intaked into a Lambda function in our logic infrastructure. It can be then used with our digital twin infrastructure, which is called Ledger. And then it can really natively and easily interact with our integrations infrastructure to go out to your cloud. So yeah, Of course, we do provide that level of customization to some people who really want to get in there and do some hyper specific things in terms of the messaging that they want to do. But really, our solution to the complexity of connectivity at the edge is ultimately a balance between abstraction and customization. We provide an abstracted package from multi-radio, which is a type of abstraction, of connectivity, to automatic connectivity management, which is an abstraction of connection, and then to a monolithic event stream, the publish ecosystem, which is a abstraction of messaging. And we do still afford the most pernicious customer engineer with a little bit of extra work that they can, massage those abstractions. But what I like about, that particular stack is that it keeps that detail work along the kind of happy path of how we like to see people use this particular platform. So yes, abstraction is good. Thank you so much for listening. I'd love to hear what kind of questions you might have about the product or about the problem or about solutions that you have to it.
Fantastic. Thank you so much. Now, are there any questions? I know there was a little bit of interest. What was the deal over here? Can I bring you the mic? Oh, you know each other. Can I ask you to explain what the issue was at all?
So what we were talking about is that we have a particular use case for the particle unit. We're using that actively now. And so we primarily use it not for its current connectivities out to via the radios that are on it, but we use it basically because of the platform that it has for device management, for integrations, for the simplicity of basically saying, okay, publish, it goes out, it connects. So, and by doing that allows us to have a much simpler overhead in terms of our engineering and our software efforts. Even though we're not using the radios themselves, we have a particular, path for doing our radios in a different way, but we're using that in order to kind of leverage what they've done from their software and their cloud platform and integrations with that. So.
Fantastic, interesting one. Few nods around the room. Does anyone else have a question on any topic or on any of that? Disagree, agree? Anything?
Here we go.
Nice. Right, let me come over with the microphone.
Hey, just out of curiosity, can you use some of the radios to receive data and then you use the other ones to send out data? Is it async or can you do it synchronously?
Yeah. Okay. So first of all, obviously it should be clear that both, upstream and downstream communications are our lifeblood, regardless of, whether or not you're going with our multi-radio product or a cellular product. It's definitely an up and down situation. And yes, like as we work on, deploying this automatic connectivity management solution, we're very, very much interested in managing what does it mean to specify a radio for a specific task internally. So yeah, the ability to ensure that one radio is kept up for downstream communications while others are used for upstream communications is definitely top of mind. Yeah.
Thank you.
Thank you. Any more? Right, let me come over this side. Gonna get my steps in.
Actually, it's not a question. It's just I want to mention that I came up to use particles since 2017, and I bought the first one. It was called Electron.
Yeah.
And the problem was I have to design a motherboard that accepts 40 to 20 milliamp from the vibration sensor. You've mentioned about vibration. We bought a vibration sensor in a heavy machine, and then I found out last year you start bringing this monitor one, which can accept directly 40 to 20 milliamp sensor. That's really helped me a lot, and I've tested, and it is on the field now working very well.
I'm so happy to hear that. I love the monitor one. I'll actually go back to this slide. I mean, a refrain that I keep hearing from customers over and over again is like, we kind of don't want to do hardware anymore. Like we really don't. Hardware is really, really hard. I love hardware. My background is hardware, so I want to do hardware forever. But there's a lot of customers who would love to use a gateway that they can white label. This particular gateway has the ability to accept daughter cards that your wonderful hardware team can construct, make sure they're on, everything is quite nice, but it fits directly into an enclosure that's IP rated and, ready for your logo to sit on top. That's definitely the idea of something like the Monitor One. It's really ready for that industrial situation. Yeah. Thank you. I'm so happy to hear that. Yeah.
Sorry. Right. Any more questions? Thank you very much, Marek. Let's give Marek a big hand.
Excellent. Thank you.